Hi, so in this video, we're gonna be proving trigonometric identities. So for these types of problems, the approach you want to take is you first want to identify one side as the more complex one, and then one side as the simple side. And the simple side, you want to get the complex side to end up looking like the simple side. So you will only be altering the left side, which is, okay, yeah, so this is the side that you're going to alter. And then the right side, you're just going to keep it the same. So you're just going to keep doing algebraic operations on the left side until the left side matches the right side. So for these problems, you also can use the conjugate as a strategy in order to simplify down. So let's look at this example right here. We took the conjugate of 1 minus sine x, which is 1 plus sine x, and then we multiplied it to the numerator and the denominator. And then after that, we FOILed the bottom, and then after we FOILed the bottom, we ended up with 1 minus sine squared x. And then after that, using the Pythagorean identity, 1 minus sine squared x is the same thing as cosine squared x. So the Pythagorean identity right here. And then we canceled out cosine x from the bottom because there's 1 in the numerator, and then you can cancel if there's one copy of something in the numerator and one copy of something in the denominator, you can cancel it out. And then after that, both sides are matching, so then you just can write a check mark and write QED. So let's start with a second example. Let's say we have secant x plus tan x is equal to cosine x divided by 1 minus sine x. So we're gonna start with the left side as the complex side. So just label it complex, or just make a mental note of that. So we know that secant x is basically the same thing as 1 over cosine x. And then we know tangent x is the same thing as sine x over cosine x. And then we know that it's equal to this, but we can write that at the very end. So after we have this, we can see that they both have the same denominator, so you can just rewrite this as 1 plus sine x divided by the common denominator of cosine x. So after this, we can use the conjugate, we can use the conjugate of 1 plus sine x. And the conjugate of 1 plus sine x is just 1 minus sine x. So then we multiply the top and the bottom by 1 minus sine x. And we can move this over to make this straight. And we get 1 plus sine x times 1 minus sine x divided by cosine x times 1 minus sine x. And from here, you can use the fact that 1 minus sine squared x is equal to cosine squared x. And again, we get this from the Pythagorean identity that cosine squared x plus sine squared x is equal to 1. So we just rearrange it into this form by subtracting sine squared x from both sides. And then you get cosine squared x. So what you want to do next after this is you substitute, you have this identity right here, right? So then you see 1 minus sine x. You can just substitute that in. So here we have 1 minus sine x. Or in the top, you can FOIL this. This will give you, or no, you don't need to FOIL that. Cosine squared x. Oh, you do, but you just substitute it back in over there. And then you have cosine squared x, cosine x, 1 minus sine x. is equal to, okay, yeah. And then you take this, you cancel out one copy of cosine x and you leave that in the top. And then you just have 1 minus sine x in the bottom. And yeah, that is equal to what we had up there. Yeah, so we write QED. Okay, let's move on to our next problem. So let's say we have 1 plus sine x divided by cosine x plus cosine x over 1 plus sine x, and this is equal to 2 secant x. So let's start with the left side as the more complex side, obviously. So seeing that this is the more complex side, we can combine this into one fraction. So it's going to be 1 plus sine x squared plus cosine squared x divided by cosine x 1 plus sine x. And this is going to equal to 2 secant x. I guess we can write that. Okay, now we expand and we simplify the numerator. So let's just FOIL 1 plus sine x. Write this off to the side. And from this you get 1 plus 2 sine x plus sine squared x from FOILing it. And the numerator, yeah, that's just going to be 1. Okay, yeah, and then you plug that back in. That's just going to be 1 plus 2 sine x plus sine squared x plus cosine squared x, all divided by cosine x times 1 plus sine x, yeah, is equal to 2 secant x. So then we can cancel things out, and that will just give us 2, and we can also factor out the 2, and that will give us 1 plus sine x divided by cosine x times 1 plus sine x is going to be equal to 2 secant x again. Now from this, we can cancel this common factor out, and then we get 2 cosine x is equal to 2 secant x. But remember, secant is just the reciprocal of cosine. So you can rewrite that as 2 over cosine x, and then yeah, they're both equal to each other. Or you could do it the other way around too, but you know, same thing. QED. Got it. Okay, now for our last problem, let's say we have sine theta divided by cosine theta plus 1 plus cosine theta minus 1 divided by sine theta. And let's say this is equal to 0. So let's start with the left side and let's use the common denominator of sine theta times cosine theta plus 1. So we're going to make this our common denominator. So yeah, we have sine, you can just cross multiply with the, like this. So you have sine squared theta plus cosine theta minus 1, and then that's cosine theta plus 1 is, okay, yeah, and then you divide it by these two, cosine theta plus 1 times sine theta. Is equal to 0. So now you can simplify the numerator. Yeah, you can simplify the numerator. This is gonna give you, you can write that down here. Sine squared theta plus cosine squared theta minus 1 divided by sine theta times cosine theta plus 1 is equal to 0. But you also know that via the Pythagorean identity that sine theta plus cosine theta is equal to 1. So you can just write that as 1 minus 1 over sine theta times cosine theta plus 1 is equal to 0. And you know 1 minus 1, that's just equal to 0. And 0 divided by anything is just 0. So then you have 0 is equal to 0, which is, of course, a true statement. So QED. And we're done for this video. Thanks.